everyone. In this video, I am going to be going through some problems from the summer packet. So we're going to really focus in on questions number 5 and 6 in your packet. So if you have it and you've completed it, maybe take it out so you can check along with me. And if you haven't done it, maybe this is a great opportunity to start to work on that so we can practice reviewing some of the skills that we've learned. So question number 5 looks at applying some of the things that we know about factoring and like all different types of factoring to solve different types of equations. So there's exponential in there, there's square root, there's rational, quadratic, higher order polynomials. So that's what question 5 focuses on. And question number 6 kind of builds on that a little bit, but it's looking at the properties of logs and exponents in order to solve those types of problems and problems involving logs and exponents. So question number 5, let's see. I'm going to start with C. So I'm going to skip around a little. I'm not going to do every single problem. There's a lot. But hopefully it gives you a model if there was anything you were wondering about. So for C here, I mean, there's 3 terms, right? So think back to if this was x squared minus 26x plus 25, how would you factor it? It's the same thought process, right? So the only difference is instead of this being x and x when you look at the 2 binomials, it's x squared and x squared, right? So then, well, what's going to go in here? Well, I'm going to need a 25 and a 1, and they're both going to have to be negative, right? So if you were to multiply this out, this is what I would end up with. So then I'm going to use the zero product property to set each term equal to 0. I guess there's 2 things I could be doing, right? So you've got x squared equals 25, and when you go to take the square root, you get x is plus or minus 5, right? Here you get x squared equals 1, and when you go to take the square root, you get plus and minus 1, right? So maybe in this step, what you could also think through is I could factor that even more. That's difference of squares. Right? They're 2 perfect squares. So that's really x plus 5, x minus 5, right? And same thing here, 2 perfect squares, difference of squares, x minus 1, x plus 1. So this is also a great thing to remember. And then I have my 4 linear factors, right? And I could set each one equal to 0, and I'm still going to get those same results, right? So it's just another way of thinking about it. And it is good to recall and remember difference of squares. So I'm going to go ahead and I'm actually going to skip ahead to F over here. So F, ooh, what should we do here? What's a good first step? I'm going to go ahead and subtract 2 times x minus 1 minus 2 times x minus 1. So you've got 4x plus 7 times x minus 1 minus 2 times x minus 1 equals 0. So right here, right, we haven't actually factored, we just rearranged things. But if you look at this and this, the 2 things that are being subtracted, they have something in common, right? And when you have something in common, you can factor it out. So I can go ahead and factor out an x minus 1, right? So like divide this first term, this first chunk by x minus 1, and I'd be left with 4x plus 7. Divide this chunk by x minus 1, right? Pull that out, factor that out, and you're going to be left with minus 2. Right? So, oh, look at that. X minus 1 times 4x plus 5. Here. Right? So now 0 product property, x minus 1 equals 0, and 4x plus 5 equals 0. So you're going to have that x equals 1. And x equals negative 5/4, right? Subtract 5 and divide by 4, right? So if you had any trouble with this one, it's a very similar concept, right? It's the same general idea. So maybe if you had trouble with E, use what we just did with F to help. Help. And try it. I'm also going to look at G. What should I do with G? Right? Here's a 3rd degree polynomial, a cubic function. Well, let's find the greatest common factor, right? And let's factor out the greatest common factor. Well, what do all three of these terms have in common? 2x, right? They're all divisible by 2x. So I'm going to be left with x squared. And be careful that you're not just dividing by it, because then you're going to lose, right? That's throwing out one of the factors and one of the solutions. So 2x, x squared minus 6x plus 9 equals 0. 2x, factor this trinomial. So it's going to give you, what is this? X minus 3 times x minus 3. Oh, it's a perfect square. Right, so I'm going to have my two solutions. 2x equals 0, so x equals 0. And then it's a repeated solution, right? Remember what that means when you graph it? Remember the word for that? It starts with an M. A multiplicity. Right, so like, no, this wasn't asking you to graph it, but it's interesting to think about, right? So I have three solutions, so one of them is repeated, right? So it's 0, and then I have one at 3. And remember what happens is, oh, it's going to increase. And they have different end behaviors. It goes through, and then since this 0 happens twice, it bounces back, right? So that's a good thing to recall too. Like it's repeated because this was a perfect square. Very similar idea to what you're doing in H, a similar way to start it. Okay, let's see, what's next? Let's do I. Let's put everything on the left side. 9x cubed plus 36x squared minus x minus 4 equals 0. What should I do here? How should I factor this so that I can successfully solve it? Hopefully you're thinking factor by grouping. Yeah, then you can group and factor out what's common. So here I'm going to factor out 9x squared. What are you going to be left with? X plus 4. Here I'm going to factor out a -1, and what am I going to be left with? X plus 4. Right, so then let's look here. What do these two have in common? Oh, check that out. They both have an x plus 4. And you're going to be left with 9x squared minus 1. Right, so I guess there's a few ways I can think about this. I can actually factor this further. What does this factor into? 3x minus 1 times 3x plus 1 is maybe what you're thinking, right? So I could go ahead and do it like this, and then I'm going to get that x plus 4 equals 0, so I'm going to have x equals -4. I'm going to have 1/3, and I'm going to have -1/3, right? Maybe you were at this step, and you wanted to solve it, and you had x plus 4 equals 0, so x equals -4. And then when you said 9x squared minus 1 equals 0, 9x squared equals 1, x squared equals 1/9, and you go to take the square root, that's going to give you plus and minus. The square root of 1 is 1, the square root of 9 is 3. Right, so they both arrive to this solution, but again, it is good to remember, what is this called? Difference of squares. Good thing I'm not going to do K. I'm going to skip down here to L, right? So it's a similar idea to what you're doing in these two, right? But I wanted to start with this one. So when I'm solving this for x, I mean, maybe you're going to try to get a common denominator. What I'm going to go ahead and do is just try to eliminate the denominator, right? So if I do whatever I do, as long as I do it to everything, I'm allowed to do that, right? Like I'm allowed to multiply through and like dilate this. I'm allowed to multiply through by a number. So I'm going to choose to multiply through by the greatest, or the least common denominator. Mixed up my words there. So the least common denominator is x squared minus 4, right? That's coming from, I mean, if you can really think about, that's x minus 2 times x plus 2 is what I'm multiplying through by. When I multiply this first term by it, I'm going to end up with x plus 2 times x plus 2, right? The x minus 2s are going to cancel. When I do it to the second term, the x plus 2s are going to cancel. So I'm going to end up with x minus 2 times x minus 2. When I do it to the right side, well, the whole denominator is going to cancel. This is x plus 2 times x minus 2. So I'm going to end up with 8 minus 4x. And now I don't need to worry about the denominator. So let's see, multiply this out. X squared plus 4x plus 4 plus x squared minus 4x plus 4. Let's move that stuff over. Minus 8 plus 4x equals 0. And let's see what we've got here. So x squared and x squared is 2x squared. 4x minus 4x, those go away, plus 4x. And then 4 plus 4 is 8, minus 8 is 0. Oh. Let's see, what do these have in common? Factor out of 2x, and you're left with x plus 2. So we get that x equals 0 and x equals negative 2, and you can check those as well. Let's do a few more from this. Let's do p, right? So these are very similar to that one. Like m is very similar to what I just did. So for p, and n and o are going to be similar to what we're going to do for p. So if you're able to follow along with p, that's going to help you with n and o. So I'm going to start by adding 2. What should I do next? Square both sides. Careful when you square the side. I'm going to be left with x plus 22 equals x squared plus 4x plus 4. Let's rearrange it. I'm going to move everything to the right. 0 equals x squared. 4x minus x is 3x. 4 minus 22 is negative 18. And then factor. X. 6 and 3, right? Plus 6. X minus 3. So your two solutions are x equals negative 6 and x equals 3. We probably want to check it to make sure that it works. Right, so if I plugged in a negative 6 plus 22 is 16. So 4, right? Yeah, 4 minus 2 is 2, not negative 6. So this actually doesn't work. Remember what that's called? Extraneous. Right, it didn't work. When you plug in 3, does that work? 3 plus 22 is 25. 5 minus 2 is 3. Oh, that works. Right, so this is actually my only solution. This is an extraneous solution. And that's what, think about what a square root function looks like, right? Like, not, it's just the top half. Let's do 3 more of these, and then we'll finish up with 6. So similar idea. I'm going to go ahead and I'm going to add, oh, there's 2 square roots here, isn't there? So 2 plus square root of x, right? Same process. I'm going to go ahead and square both sides. So this is now going to be 2x plus 7 equals 4 plus 4 root x. So didn't get rid of the square root, and then plus x. Okay, let's isolate this, because what are we going to have to do to get rid of it? Square it. So minus 4 and minus x. So I'm going to have x, right? 2x minus x. 7 minus 4 is plus 3 equals 4 root x. And I'm going to go ahead and square both sides again. X squared plus 6x plus 9 equals, careful here, right? It's, what is that when you square it? 16x. And I'll go ahead and subtract that. I'm going to go over here. X squared, is that minus 10x plus 9 equals 0? And now that is something you can factor. What does that factor into? X minus 9, x minus 1. So x equals 9 and x equals 1. What should we do? We should probably just check it, right? So 18 and 7 is 25, so that's 5 minus 3. That works. You plug in 1. You get 9 here, right? 2 plus 7 is 9. So 3 minus 1 is 2. That works as well. Let's do 2 more. Oh, no. I want to do this one down here, right? Let's finish up with some exponential. So this was actually, if you all recall, what we were doing in AAF right when we were leaving back in March. How crazy. So we want these to get to be the same base, right? They do have a common base of 3. So I can change this to be expressed as 3 squared x, right? And I can express this one as 3 cubed x plus 1, right? So you just want to be careful here. So this is 3 to the power of 2x, and this is the 3 to the power of 3x plus 3, right? That gets distributed, so just be careful there, right? Like it's the entire thing. And then because the bases are the same, we know the exponents have to be the same, so I can ignore the bases, ignore the 3's, and set the exponents equal to each other and go ahead and solve. So it's going to give me negative x when I subtract 3x, so x is going to be negative 3. That rhymed. Let's do one more of these. Let's do v. That looks fun, doesn't it? What is going on here? The square root of 5. What could you do? This is messy. Oh, what is the square root of 5? When you have the square root, that's the same thing as saying 5 to the power of 1/2. Right, so let's change that. 5 to the power of 1/2 times 1 minus x equals, well, 625. 625 is 5 to the power of 4. Right, so, oh look, check that out, same base. Go ahead and distribute this, don't forget. 1/2 minus 1/2 x has to equal to 4. Right? So negative 1/2 x. You know what? I don't want it to be a half. I'm going to multiply everything by 2. 1 minus, you could, I just didn't want to deal with the fractions. 1 minus x equals 8. Subtract 1, negative x equals negative 7. So x equals 7. Right, and you can go ahead and even check that if you really wanted. But I guess you could have also changed this if you really wanted to have a, right, so this is actually the same thing as the square root of 5 to the power of 8. If this is 5 to the power of 4, right, it's going to be the square root of 5 to the power of 8, and that could have gotten you directly to this point if you wanted. If you didn't want to multiply through by 2, that would have been fine as well. Okay, let's finish up with a few from number 6 as well, which this is kind of a good segue because we were just talking about exponents. So I'm going to start with D, right? So if you remember logs, it's what power turns 2x into 27, right? So what the power that turns 2x into 27 is 3. So I could rewrite this as 2x to the power of 3 equals 27, right? So this is the exponent, this is the base, and this is the argument, right? And there were some rules for it, right? Maybe you remember some of them. Do you remember any of them? Like, what can the argument not be? What has to be true about the argument? What has to be true about the base? Let's see. So 2 to the power of 3 is 8. X to the third equals 27. And I guess there's a number of things I could do right now. I'll go ahead and divide by 8, though. X cubed equals 27/8, and then I'll go ahead and take the cube root. Right, so x is going to equal to, what is that, 3/2. What happens there? What happens when you put, what is 2 times 3/2? 3. Does that make sense? 3. The third power is 27. Oh, it does. How cool. Let's do a few more. F. Let's do F. This is a quick one. Actually, just really quick, what does have to be true about the base? Can the base be negative? No, right? So something like this, your x value is only going to be positive 9, right? Even though when you're solving it, you're going to have x squared equals 81, and you might be conditioned to think, oh, this should be plus or minus 9. It's not going to be the negative 9. It's only positive 9. You're or your base is not going to be negative. Okay, sorry, I just want to say that. What happens here? Well, logs and exponents, it cancels out, right? Like, let's say I was going to go try to do this. Log base 8 of x equals log base 8 of 5. Oh, check that out. If their bases are the same, x is 5, right? So recognizing that these are like inverse operations and they just end up canceling each other out, and x is 5 is great. Let's do h. When you subtract logs and they have the same base, wait a minute, what's the base? No, it's a base 10, right? Log is log base 10, right? The common log. So when you're subtracting, you're actually dividing the arguments. So 2x plus 3 divided by x equals log of 4. I'm able to ignore the log because it's the same, right? So their arguments have to be equal. Then I can go ahead and solve this. I'm going to multiply both sides by x. 2x plus 3 equals 4x. 3 equals 2x. So x has to be, what is this, 3 halves. Let's see, does that work? When you plug in 3 halves times 2 is 3, so this is going to be 6 minus, or 6 divided by 3 halves. So times 2/3. Oh, that works. That gives you 4. Fantastic. Okay. Final one. Let's finish it off with I. So all of them have the same base. So log base 5 of, when you're adding, we're going to multiply the arguments. So this is x squared plus 7x plus 12 equals 2x plus 6. So I'm ignoring the base. I'm ignoring the logs. Subtract 2x. X squared plus 5x plus 6 equals 0. Let's see, factor that. X plus 3 times x plus 2. So I've got x is negative 3 and x is negative 2. Let's see. When you plug in negative 3, oh my goodness, negative 3 plus 3 is 0. Argument can't be 0. So that's not right. What about negative 2? Does that work? Negative 2 plus 3 is 1. Negative 2 plus 4 is 2. Negative 2, negative 4 plus 8. Yeah, that works, right? Yeah, that works. Right, but this one didn't work. My argument should not be 0. Think about where an asymptote is when you're graphing an exponential function. Your answer is not ever going to be 0, right? There's not going to be a number raised to a power that gives you the result of 0. That's why there's an asymptote and it gets exponentially close to it, but never actually touches it. So for those of you that have not finished these 2 questions, this would be a great time to go back and work through some of those problems. You guys do have access to summer packet, and if you need to go back and rewatch anything, feel free to do so. Thanks, everyone.